Welcome to 9.4, linear programming, finding maximum and minimum values and then plugging them into another function. That's what you're doing today. So here's the function we're looking at. We need to get the maximum and minimum values. So basically what we're doing is we're plugging in all these vertices. So your choices are to graph your functions, find where they all meet for your vertices, and then plug them in, such as C equals, we'll go clockwise starting at 2, 0, okay? So 3 times 2 plus 2 times 0 plus 5. What does that equal? Well, 6 plus 0 is 6 plus 5 is 11. All right, and then you go to the next one. All right, so that was 2, 0. Let's do 0, 2. All right, 3 times 0 plus 2 times 2 plus 5. That's equal to 9. Okay, and then we keep going. 0, 4. C equals 3 times 0 plus 2 times 4 plus 5. That's 13. All right, and then we get 3, 5. And we assume this is going to be the best answer because it's the highest for maximum. 3 times 3 plus 2 times 5 plus 5. And that's 24. See, 9 plus 10 is 19 plus 5 is 24. All right, and let's do 2 more. Let's just raise all this up just a little bit. All right, so let's do 6, 2. Now you're not sure which one's the best one. All right, so this is 3 times 6 is 18 plus 2 times 2, 4, that's 22, plus 5 is 27. This one seems to be the biggest one. And then we have 5, 0. Let's try that one. C equals 3 times 5 is 15, plus 2 times 0 is 0, plus 5, that's going to be 20. All right, so our maximum is going to be 27 at 6, 2, and our minimum is going to be 9 at 0.02. So it may seem obvious what the answer is, but you still have to check. All right, let's go on. Okay, so we're sketching the graph of all of these functions, and then we're going to do the exact same thing we did on the last problem. All right, so let's graph this, here. Okay, first, x is greater than or equal to 0. So that's a vertical line going through the x-axis, or the x-axis at 0. So let's do all these in blue. It's a solid line, sorry, not dotted. And it's greater than, so we're going to shade to the right. Okay, and then we have y is greater than or equal to 0. Okay, so again, that's going to be a solid line going through the y-axis at 0, shaded up. So far we are in the first quadrant. Now we have to do the 3x minus 4 greater than or equal to negative 12. Okay, so let's move 3x over. So it'd be negative 3x minus 12, because it was a negative 12, and divide everything by negative 4. That changes our direction of our inequality. That makes us positive 3/4 x, and negative 12 divided by negative 4 is positive 3. So it's equal, so we go through it 3. It's going to be a solid line going up 3, 1, 2, 3, and over 4, 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. It's important that we get all of this correct. Or down 3 and over 4. Okay, and it's less than, so we're shading down here. Next one, we're going to do 3x plus 2y less than or equal to 24. So again, do all of these things. Subtract 3x, negative 3x plus 24, divide off the 2, and we get y is less than or equal to negative 3/2 x plus 12. So this goes through at 12, which is going to be right there. And let me see if I can move all of this without, nope, it's all attached. Okay, and it goes down 3 and over 2. Let's put this all back where it was. There. Down 3, 1, 2, 3, and over 2. 1, 2, 1, 2, 3, over 2. And that's where they meet. 1, 2, 3, and over 2. Right, so we make a straight line this way. we have two vertices, and it's less than, so again, it's shading in here. Okay, and then we do the last one, 3x minus y less than or equal to 15. So we get negative y less than or equal to negative 3x plus 15. Divide off the negative, y is greater than or equal to positive 3x minus 15. I apologize, just realized my microphone wasn't on correctly. All right, so this goes through at negative 15. So we have negative 4, 8, 12, 13, 14, 15. Okay. So it goes through at negative 15. It's solid. And we go up 3, 1, 2, 3, and over 1. 1, 2, 3, over 1, 1, 2, 3, over 1, 2, 3, over 1, 1, 2, 3, over 1. Let's do this in blue. 1, 2, 3, over 1. There's the other one. So this is a solid line going up through that area. It's greater than, so it's shaded above. So let's do some shading here. Exactly. These are all solid lines, so on the line does count. And that's the picture we're looking at. So let's come up with all of the coordinates. So we have 0, 0. We have 0, 3. 1, 2, 3, 4. And 6. 4, 6. And see, 4, 5, 6, 3. And we have 5, 0. So we got to check all of those. So let's move everything up. And let's start our process here. First of all, what was our C? C is 3x plus y. Okay, so C equals 3x plus y. Let's just put it right there. Make sure that's what we got. Yep. All right, so now we plug in all these values. So what do we get at, let's just start at the top, 4, 6. What does C equal? 3 times 4 plus 6. 12 plus 6 is 18, so this is C. Let's do 6, 3. Just go around in order. So 3 times 6 plus 3. 18 and 3 is 21. And 5, 0. 3 times 5 plus 0 is 15. And as you get through this, you can go a little bit faster. 0, 0 is going to be 0. And 0, 3 is going to be 3. So we have our maximum and minimums. So our maximum is 21 when we're at 6, 3. And our minimum is 0 at 0, 0. Okay, so we're just finding the minimum value of C here. On the last one, we were finding the maximum, but I did both of them anyway. So let's go ahead and do the exact same thing we're doing. Let's plot all of the points. Again, I'm not sure exactly how wide or how tall the graph needs to be. Let's just do it. X is greater than or equal to 0. Again, goes through the 0. We'll do it all in blue again. It's a solid line because it's equal and shaded to the right. Y is greater than or equal to 0 is the horizontal line going through y-axis at 0, and it's greater, so again, we're shading up. So at the moment, we're in the first quadrant. Now let's do the other ones. 2x plus 3y is greater than or equal to 12. Just solve them and plot them. All right. At this point, I shouldn't need to go through this, but I'll continue to talk, but I'm going to go faster. Okay, so now this goes through 4. It's solid because there's an equal sign. Down 2 and over 3. Down 2 and over 3. Down 2 and over 3. So here's our line. It's greater than, so it's shaded up. All right, so now we have a pretty big picture at the moment. Let's go to the next problem and do 2x plus 5y greater than or equal to 16. So 5y is greater than or equal to negative 2x plus 16. Divide off the 5. So y is greater than or equal to negative 2 fifths x plus 16 fifths. 16 fifths is 3 and 1/5. Okay, crazy stuff here. All right, so, oops, let's get rid of that. Now it goes through at 3 and 1/5, which is right there, and goes down to 1, 2, and over 5. 1, 2, 3, 4, 5. Okay, down 2, 1, 2, and over 5. 1, 2, 3, 4, 5. All right, so I'm going to just draw this part. And what do we have here? Where did they meet? They met right there. Okay. And it's greater than, so it's shaded above. And it'd be nice to know where this x-intercept is. I don't need to worry about the y-intercept because the constraint puts me at this point. So this goes down. It'd be nice if that was a nice neat point, which it looks like it is. Let's figure it out. To get the x-intercept of this equation, then you plug 0 in for y. So if we plug 0 in for y, that becomes 2x greater than or equal to 16. And so there we see x is 8. So 4, 5, 6, 7, 8. Right there. I guess I had my marker at a different spot. Okay, so now, since it's asking for a minimum, there's a reason it's not asking for a maximum. If we shade this, the shading is way up there. It doesn't stop. Okay? So there is no maximum. It's infinite. The maximum is infinity. Okay, there is no single maximum. All right, so there we have it. Let's look for the minimum here and see what we get. So our left point here is 0, 4. This point, next one is at 3, 2. The next one is at 8, 0. And those are the only three we need to check. All right, so let's write our C equation down. Let's write this differently. Let's do 3x plus 6y is equal to C. All right, let's move everything up so we can just see our values. So when we're at 0, 4, 3 times 0 plus 6 times 4 is 24. Okay, and 3, 2. 3 times 3 plus 6 times 2. 9 and 12 is 21. And 8, 0. 3 times 8 plus 6 times 0 is 24. Okay, so we got two 24s and a 21. It's wanting the minimum because there is no maximum. So the minimum is at 3, 2. Very interesting that that would be the minimum. So you can't go by the visual look of this. You can't just think, oh, it's going to be 8, 0. That's going to be the smallest one. No, it depends on what function they give you. Okay, let's move on. Okay, so here we're going to get the maximum. And we're going to describe the set of points. So that should give you an idea. It's going to be a whole bunch of stuff here. Okay, so let's just go ahead and start plotting everything. Again, you have x is greater than or equal to 0. So it's going that direction. And y is greater than or equal to 0. So this is still in the first quadrant at the moment. That's what we're looking at. Now let's do the x minus 2y is greater than or equal to negative 8. All right, so let's move the x over. Negative 2y is greater than or equal to negative x minus 8. Divide off the negative 2, which changes the direction of our inequality. So y is less than or equal to positive 1/2 x plus 4. So this goes through at 4. And these are all solid. They all have equal signs. And it goes up 1 and over 2. Up 1 and over 2, up 1 over 2, 1 over 2. So that's that line. Let's try to make it as exact as we can. Okay. Okay, and it's less than, so it's shaded down. So far, this is where we are. And let's do the next problem. 1/2 x plus y is less than or equal to 6. So that's y is less than or equal to negative 1/2 x plus 6. So again, it goes through at 6, solid. Goes down 1 and over 2, and they meet there. So down 1 over 2, down 1 over 2, down 1 over 2, and try to make it as accurate as you can. and it's less than, so it's shaded in towards each other. And we have one more. 3x plus 2y is less than or equal to 24. So 2y is less than or equal to negative 3x plus 24. Divide off the 2. And y is less than or equal to negative 3 halves x plus 12. Okay, so 12 is about right there. And we go down 3. 1, 2, 3, and over 2. 1, 2, 3, and over 2. There's that one. 1, 2, 3, and over 2. 1, 2, 3, and over 2. Okay. And it's less than, so it's shaded underneath. Now let's take a look at the shading. And try to get it to look nice. Okay, so there we go. Now, what are all of the points? So we have 0, 0, we have 0, 4, we have 2, 5, and 6, 3, and 8, 0. All right, so we got to put all those in. So I just get rid of this stuff, and we'll start to write it out. 2x plus 4y is equal to c. So let's start with 0, 0. So we want the maximum values here. So that's going to give us 0. 0, 4, that's going to give us 16. 2, 5. So 2 times 2 plus 4 times 5 is 24. And then you do 6, 3. 2 times 6 is 12, and 4 times 3 is 12. That's 24. And then we do 8, 0. 2 times 8 is 16. All right, so we have two 24s for maximum values. So any of the points from 2, 5 to 6, 3, and we can go ahead and highlight that. This part right here, I guess we could do red, maybe better. That value, those values right there, that's going to be, those are all going to be 24s no matter what you put in there. Okay, so that's your set of values. Okay, so if we look at negative 2 as our slope in this equation, okay, so y equals negative 2x plus p over 350, okay. We solve for p and figure out what our maximum profit would be at each of the vertices, okay? So let's add 2x to the left and then multiply everything by 350, and we'll see what we get here. So 350 times 2 is 700, and 350y equals p. Okay, so now we plug in all these values. So 0, 0 is going to give us 0, okay? And 0, 8 is going to give us 8 times 350, which is 2,400 and 400, 2,800. Yeah, 2,800. And then let's just go down the list here. 2, 7. So 1,400 and 7 times 350 plus the 1,400. That's 3,850. And then we do 6, 3. So 700 times 6 is 4,200, and 3 times 350, that's going to give us 5,250. And then we do 8, 0. So 700 times 8 is 5,600. All right, so the maximum value when your slope is negative 2 is going to be at 8, 0. And in the beginning of this, it says writing the objective function, okay, gives us this in slope-intercept form. Then compare the slope with the slopes of the line segments, the slopes of each of these lines, okay? So if we put these in slope-intercept form, that'd be a negative x divided by 2, so a negative 1/2 is that slope. Subtract x divided by 1, that's just negative 1. And this slope here, if we subtract 3 and divide off the 2, that's negative 3/2. So it's if we list all those, we have negative 1/2, we have negative 1, negative 3/2, and then it says to check negative 2 for what we're doing in this one. And if you put all of those, each of those in for your slope, it still is going to come out that negative 2 gives us the most profit. And if you think about it, everything stays the same in this equation. The y-intercept is p over 350, so what's going to give us the biggest p value, which is right here? And as we see, negative 2 gives us 5,600. All right, and if you plug all those in, if you put those in, they're going to give you smaller and smaller values. Okay, so thinking about it, it should be obvious that that negative 2 is going to give you the biggest y-intercept for what it is that they're looking for. And that's it. That's all you needed for this lesson.